Good afternoon. I am Dr. P. Usharani, Professor EEE S&H Department, RMT Engineering College. I am going to brief about the topic of Nodal Analysis Technique. The other name for Nodal Analysis Technique is Node Voltage Method. Here, this method is useful for analyzing electric circuits by calculating voltages at different points, or we can say that is different nodes in the circuit. What is a node? If you take care, means node is a point in a network where two or more circuit elements meet at that point. Here in this method, one of the nodes were taken as reference node. This reference node, or we can say zero voltage point. Okay, zero voltage point. The potential of all other points in the circuit are measured with respect to the reference node. Here we are the application of Kirchhoff's current law as used to create a series of node equations that can be solved for node voltages. That is, Kirchhoff's current law as total current entering into a node is equal to total current leaving the node. These equations are based on Ohm's law, that is I is equal to V by R. Here in a circuit containing n number of nodes are there, number of equations is n minus 1. So one is reference, and based on the reference, that is zero voltage point, we can take the other nodes are non-reference points. We can solve the equations for the node voltages. I have taken a problem of the circuit having 6 amps current and 2.5 amps current at the other end, and the resistors are connected as shown in the figure. The elements, how they are connected with the values I have mentioned. We are going to find out the voltage at the node. By seeing this diagram, there are 4 nodes, okay, A, B, C, D. So D point as the reference node, zero voltage point, and remaining are non-reference nodes, that is the independent nodes. Unknown voltages are there. So our objective was to find the unknown voltages VA, VB, VC. By using nodal analysis, we are going to find out. So this is the diagram. In that I am going to write the node equations applying Kirchhoff's current law. So node A I have taken. Node A, what are the incoming currents and outgoing currents we should take care. I is equal to V by R. So the leaving current is 6 amps. So I have put minus 6 here, and incoming currents, if you consider, there are voltage at point A and voltage at point B. So the voltage drop, we can say the current at the node A. So here this 2.5 as VA minus VB. So VA minus VB divided by 2.5 and VA divided by 15 ohm. Or we can write VA into 1 by 15 plus 1.25 and close that, and minus of VB into 1 by 2.5. Here one more thing we have to note, we are not considering this 5 ohm resistor. Why we are not considered this 5 ohm resistor for the voltage of VA means, this is omitted because it is connected in series with the current source. So we should not consider this. Okay, omitting this 5 ohm resistor in this point. So after simplification of this node equations, 0.467 VA minus 0.4 VB, which is equal to 0.6. At node B, we are considering, you are going to apply the current leaving and current entering. So only current entering here, there is no leaving, there is no current source here, so equal to 0. What are the currents here as? This if you consider, this is VB if you take 1 by 2.5 plus 1 by 20 plus 1 by 6 and minus of VA into this 1 by 2.5. Similarly, minus of VC into 1 by 6 this resistor. So this equation as node equation at this node. So after simplification, minus 0.4 VA plus 0.617 VB minus 0.167 VC equal to 0. Similarly, at node C, if you have taken care, the incoming current is 2.5 amps. So in the right hand side, I have put the 2.5 and the other end VC if you consider, VC 1 by 4 and 1 by 6, you have to add this. So VC into 1 by 6 plus 1 by 4 minus of VB into 1 by 6. So this is the node equation. Simplified means minus 0.167 VB plus 0.417 VC, which is equal to 2.5. So at node A, B, C, we have written 3 node equations based on Kirchhoff's current law and applying Ohm's law. Okay. So after solving these 3 node equations, we have obtained VA as minus 30 volt, VB as minus 20 volt and VC as minus 2 volt. Thank you.